Welcome to today's Manufacturing Engineering Media webinar. Our topic is Trendsetting Efficiencies, using a single 3D printer in a fast-paced prototype environment, sponsored by Stratasys. Hello, I'm Jim Sawyer, Senior Editor at ME Media. Before the presentation begins, I'd like to provide some background on what we will be doing today. Our sponsor, Stratasys, manufactures 3D printing equipment and materials that create physical objects directly from digital data. Its systems range from affordable desktop 3D printers to large advanced 3D production systems. Our program today offers two presentations. Our first presenter, Eric Ziley, is Program Manager for Prefect Corporation. He will offer insights into how Prefect has developed a process to achieve maximum efficiencies from its 3D printer. Our second presenter, Susan York, is North American Business Manager Materials for Stratasys. She will provide insights into Stratasys' leadership position in 3D printing and what the future holds for this exciting manufacturing technology. You will be able to ask questions during both presentations using the Q&A box that appears on the right side of the screen. Eric and Susan will answer those questions once both presentations have been completed. If time runs out before we can get to all the questions, we will make sure the answers are emailed to you. And if you have any questions about any other aspects of ME Media's webinars, please email me at jsawyer@sme.org. Now, here is Eric Ziley.
Thank you, Jim, and good afternoon, everyone. We'd like to thank you for taking the time out of your busy schedule to join us for today's webinar entitled Trendsetting Efficiencies using a single 3D printer in a fast-paced prototype environment. We are Prefect Corporation based in Rochester Hills, Michigan, just north of Detroit, at the heart of the Motor City. We are entering our 35th year and have a very diverse background within the transportation industry. We bring innovation and creativity to reality, from vision, concept, design, and prototype to production-ready specialty vehicles like the 2014 SRT Viper. We'd like to take a few minutes to showcase a little bit about what we do and who we are as an organization. With any growing business, you need to learn to adapt to the changing marketplace. For the past decade, we have been heavily involved in what is called subtractive manufacturing through the use of our 6 CNC machines. While this is still an integral part of our business, we found it very important to start entering the field of additive manufacturing through the use of a Connex 500 3D printer. We have numerous uses for this technology in our business that we plan on highlighting throughout our presentation. We build a variety of models both inside and out, whether it be a new concept vehicle for the North American International Auto Show, an inside-outside show model for an OEM, or a new soon-to-be-released reveal vehicle. We also produce new fun and exciting properties for the annual Specialty Equipment Market Association show in Las Vegas, better known as SEMA. This past year, we built a 2013 SRT Viper that showcased all of the available Mopar accessories for the car. This included exposed weave carbon fiber spoiler and splitters, carbon fiber interior accents, as well as new seat covers. This was all complemented with our heavy involvement in the SRT Viper program, where we paint all of the exterior body panels. We have also had experience in low-volume production specialty vehicles, such as the Pink Jeep Tour Trekker for Pink Jeep Tours out in Las Vegas. We built passenger pods for 30 vehicles, as well as made modifications to an existing Dodge Ram pickup truck to make it look more like a Jeep with the traditional 7-slot grille. We have also recently expanded into aerospace through the creation of cockpit and fuselage interior mock-ups for both Gulfstream and Embraer. While we have a wide variety of capabilities, one that has proven to have a very big wow factor is our interior trim. Back in 2004, we built a custom F-150 for the SEMA show that we badged the Everest. We did a full retrim of the interior, including leather seats, door panels, headliner, instrument panel, and Corian accents throughout. We also did a number of exterior modifications that truly made this truck resemble the luxury automobile market. This vehicle won Best of Show at SEMA that year and really helped catapult us into this type of show quality work. Next is the MKT concept car build that we did for the 2008 North American International Auto Show. This vehicle eventually made it into production in 2010. This vehicle was built from the ground up, starting with the driving chassis here at Prefect. This model included some of the highest grade materials, including a banana silk carpet that cost $500 a square foot. To this day, many people in the industry consider this one of the nicest concept cars ever built. Many of the parts that come off of our 3D printer end up being molded in silicone and get a casted urethane part. We will take our 3D printed part, surface it, and then pour a silicone mold. Once the mold has cured, we can then cast urethane parts in any color imaginable. However, most are done clear or red, representative of most headlights and taillights. We then have to put the casted part that is in the mold into a low-pressure vacuum chamber. This helps to remove any air pockets in the part. When building a property, it is often necessary to machine a mold for us to lay up a part that could be any number of materials, including fiberglass and carbon fiber. Most fiberglass work is done through what is called an open layup, where you apply a surface coat to the mold, lay in the fiberglass with the resin, and allow it to cure overnight. You are then able to pop the part out of the mold, trim as necessary, and start the prep work on the part. With the advancements of technology today, the use of carbon fiber is becoming more and more popular. Certain processes have allowed it to be a little bit easier and more cost-effective than in the past. If the requirement exists in production, there comes a need to represent it in prototype as well. If the desire is to show the exposed cloth weave of the carbon fiber, we will use a vacuum infusion process where you lay the cloth in dry and then suck the resin into the mold through a vacuum system. You are then left with a beautiful part that you can clear coat before installation onto the vehicle. As previously mentioned, we built 30 tour trekkers for Pink Jeep Tours in Las Vegas. We were responsible for complete design, cage fabrication, pod creation, mounting, painting, interior trim, and final assembly of each and every vehicle. After nearly 5 years of service, these vehicles are still in use. We have also had involvement with custom limo interiors that involved the fabrication of fiberglass parts, casted urethane parts, many of which were fully leather wrapped. Many of the panels even included hand-picked, machined, and treated walnut. Our biggest need for the 3D printer exists in our lighting department. We are a leader in prototype lighting creation and are well known for our attention to detail, as well as our trademark lighting controller. We can build anything from lighting mock-ups, lit corner models, show lamps, including interior lighting, certified verification lamps, and night drive lamps. Each of these lamps have a very unique and specific function and requirement. Another type of model that we build a lot of are verification models. These can be both interior or exterior models, as well as smaller corner models. Typically, most of the parts of these types of models are machined out of a machining board. However, many parts, due to their size and detail, need to be grown parts, and this is where we get heavy use out of our 3D printer. Many switches, buttons, handles, etc. may have extensive detail and or be too fragile to machine. The object provides us the flexibility to create these parts with the necessary detail without as large of a risk of breakage or loss of accuracy. Many years ago, we patented what is called a programmable vehicle model, or PVM. For nearly 2 decades, we built these for companies such as Ford, Chrysler, GM, Toyota, and Hyundai to help support customer clinics where they could assess a wide variety of likes and dislikes from a customer perspective by allowing them to move electronically any of the panels within the vehicle. You could adjust the seat height, move the instrument panel closer, door panel higher, and roof lower in order to reach your optimal ergonomic environment. This information was then all stored in a database to be studied in greater detail upon completion of the clinic. We also offer additional program support by use of our ferro laser scanning arm that helps us to validate if the parts we machined or grew are to the required build tolerance requested by our customer. We can also do the necessary seat point checks to ensure that the interior seating environment is within spec. Last year, we embarked on a very exciting opportunity to paint the entire SRT Viper in production. We acquired a 130,000 square foot abandoned Kmart, completely renovated it, and turned it into a state-of-the-art facility full of 6 brand new paint booths and all of the necessary equipment to process the nicest paint finish on any vehicle in the world. Every panel is hand-prepped, painted, wet-sanded, and polished before shipping down to the Connor Avenue assembly plant in Detroit, Michigan, where it is built. We are incredibly proud of our involvement in the SRT Viper program and helping to make this vehicle a success. Last December, we made our first visit to our local Stratasys sales office to see a demonstration of the Connex 500 in action. We were immediately impressed with the ease of use and quality of parts that were produced. Based on our experience with outsourcing rapid prototype components in the past, we knew how much use we could get out of our own machine. We did an in-depth financial analysis to determine our potential success. It became clear that purchasing our own machine was the right decision. On January 21st, we officially purchased our machine. During the next month, we did the necessary site preparation, awaiting the arrival of our machine on February 22nd. Based on our internal workload, we knew that we needed to be ready to go right out of the gate. We had an extensive backlog of parts ready to go on our very first day. On February 27th, we launched our first table, and we never looked back. For those of you unfamiliar with the Connex 500, here are a few statistics. The Connex provides precision detail vastly superior to that of standard SLA technology. Building as small as 16 microns per layer, we are able to produce parts that provide unbelievable detail and reduce overall bench time. This machine also provides exceptional tolerance, which in our industry is very important. With a 19 by 15 by 8 inch platform, we are capable of producing most of our parts on our machine. In our business, we have multiple projects going on at the same time, run by 6 or 7 different project managers. In order to manage the large number of requests coming from multiple people, we developed a software program database that helps organize all of the part submissions. Project managers are required to submit specifications such as part quantity, due date, material, detail level, and part data. This is an example of our user interface for performing part submissions. We have come to realize that without the ability to organize the massive number of part submissions, we never would have been able to be as efficient as we are. Through the user interface of the complete part submission list, our rapid prototype department is able to sort the results by a variety of categories, including due date, speed requirements, material specifications, project number, etc. This helps to assure that everyone's requests are met. In order to be as efficient as possible, there are a number of key procedures that must be in place. First and foremost, it is essential that we have the next table built and ready to go before the completion of the current platform. That way, as soon as the platform ends, we only have to pull the parts, clean the print heads, and start up the next platform. The turnaround time for this is only 15 to 20 minutes. We have a highly dedicated team that helps support each other to assure that no matter when a platform ends, someone will be available to help get the next platform started. Whether it is 7 p.m. on a Friday, 11 p.m. on a Sunday, or New Year's Day, if we have a platform ready to go, we make sure the machine is running. During our first few months of use, we have operated at 92% efficiency, meaning the machine was running on average just over 22 hours per day. The majority of our downtime was from changing from one platform to the next. As I mentioned previously, the biggest impact of our 3D printer is to our lighting department. Our 3D printed parts are used as our masters to make urethane lenses from a silicone mold. Parts are benched in order to have the highest finish level possible before being molded. Whether the part itself is used in the lamp or the casted urethane part, there are a variety of finishes we can incorporate into the part, including metallization, paint, and graining. Most of our properties are fully functional with an electronic controller unit that our customers can assess for the first time what their design looks like in real life. We also have a variety of uses on interior properties, such as the one shown. This model was an early run at the 2013 SRT Viper interior. Oftentimes, the components are either too small or too detailed to be able to provide a machined part. In these instances, we rely heavily on our 3D printer to produce these components. These components can be grained, painted, metallized, or wrapped with soft trim. The use of our 3D printer has provided additional benefits due to its high level of detail. We have been able to reduce our overall bench time or sanding time as much as 20%. As of September 7th, we had put over 4,000 hours on our machine, which puts us on pace to achieve 8,000 hours for the year. To put in perspective, there are 8,760 hours in an entire year, which would keep us at a 92% efficiency. This is roughly 2.5 times that of a standard high-end user. In that same time frame, we have built over 1,800 parts and used 115 cartridges. We'd like to thank Stratasys for all of their support over our first 6 months of operation and helping us to be as efficient as we've been. Should anyone have any questions after today's presentation or would like some more information on how Prefect can help your organization bring your design to reality, especially through the use of additive manufacturing through our Objet Connex 3D printer, do not hesitate to email me at eric.zeile@prefect.com. Again, thanks to everyone for their time.
Thank you, Eric. It's amazing how quickly Prefect has integrated 3D printing into its long-established processes. It's also amazing the level of efficiency you are seeing less than a year after acquiring the machine. Now, let's turn things over to Susan York of Stratasys, who will fill us in on where additive manufacturing is now and where it is going. Susan?
Hi, thank you, Jim. And thank you, Eric, for sharing with us what Prefect is doing as far as utilizing its Connex equipment and also the wide variety of applications that you're using in both traditional and additive manufacturing. It really is unique, the type of parts that you're using, but moreover, the fact that you've developed such an expertise in managing the queue and throughput of parts, not to mention the daily routine of maintenance, which has allowed you to be extremely effective and efficient, truly is a remarkable demonstration of managing the throughput. Today I'd like to share with you or expand upon what Eric has shared with you to talk a little more about Stratasys, its technology, and moreover, the fuel that drives, what I call the fuel that drives the engine of the systems, which specifically is the materials. By providing more and more enhanced materials, we're seeing new opportunities and applications within the automotive industry as well as many others. So first I'd like to introduce the new Stratasys. As of the end of last year, Stratasys Incorporated and Objet Geometry merged together to form Stratasys Limited, which is bringing together two leading innovators at the forefront of 3D printing. With the merger, this now allows us to provide the solutions to each and every product life cycle stage, from concept and design verification to fit, form, and function with the standard and engineering grade materials, all the way to utilizing the high performance materials in the production phase. This, we can offer 20 different systems and over 130 different materials to choose from. The use of Stratasys technology and the rapid prototyping or additive manufacturing industry is truly creating a new options for companies and individuals, such as what we heard at Prefect, but it's creating new opportunities on how things are made, how people and teams work, and directly impacting the lives through such things as custom prosthetics, for example. So we hear phrases such as rapid prototyping, 3D printing, additive manufacturing. These changes in the naming are all valid, but it's all grown as the industry has grown and as the applications have grown. So the success of 3D printing does not lie in the replacement of traditional manufacturing methods, but rather as an enhanced enabling technology that plays an exciting role in modifying consumer behavior as far as helping bridge ideas to life and expanding manufacturing offerings. Fundamentally, we believe that 3D printing is changing the world of product development and manufacturing and creating new opportunities and applications. So the technology used for both prototyping and distributed manufacturing in footwear, industrial design, architecture, engineering, and you can see the rest. Obviously, automotive is one that we've talked about today. So I'm really calling it a 3D printing revolution. The reason being is not only are we seeing the expansion into many different applications and industries, but it's starting to become mainstream. So if you look at the Gartner's Technology Maturity Report, you can see at the very top I've outlined or highlighted the consumer 3D products or printers at the very top of the peak there. This indicates that within 5 to 10 years, that 3D printing or additive manufacturing is going to be considered mainstream in the way that we do things. So as we heard with Eric's presentation, composite materials are used in aerospace, automotive, sporting goods, and consumer goods because of their strength to weight ratio exceeds any other known materials. So here I've listed a lot of different manufacturing applications that are possible with our two technologies. The fiber layup with PolyJet or FDM molds overview fiber reinforces plastics that are a group of composite materials consisted of the polymer matrix. And this is something that Eric kind of got into and showed some great examples of parts. So traditionally there have been two options for making the molds for the fiberglass layup process, and generally that's been CNC machining and handcrafting. And now with the FDM and PolyJet technology and the materials provided, an additional option is now offered with the process. So it's a good option. In addition to that, another manufacturing application that lends itself well to either FDM or PolyJet is jigs and fixtures, which are production tools that are used to accurately manufacture, duplicate, and interchange parts. They can also be used for external components to facilitate handling, calibration, and simulations of specific actions. The FDM parts can be sparse-filled on the inside, so that's going to make them lighter in weight. And because they're true thermal plastics, they're incredibly durable, which makes it perfect for this application. Some of the areas that benefit from FDM jigs and fixtures are ergonomics, such as the technician's comfort and ease of use, easy access and storage, custom design, and you can revise the parts as needed. And it's a streamlined process not to have to create the detailed drawing for the jig and fixture. So that's just another option. Additionally, one of the more popular applications today that's growing with the number of our customers is creating digital ABS injection molding tools. So if the over 130 materials that we offer don't provide the material properties that you're looking for, you can simply create a injection molding tool to create a short number of final production injection molded parts. So the PolyJet allows itself well for this process, and you can see here there's some examples that have some intricate detailing on it. So when we dive into the core technology behind Stratasys, the first I'm going to talk about is PolyJet. PolyJet is all about jetting thin layers of material down to 16 microns of acrylic-based photopolymers. That's what allows us to create parts with fine details, smooth surface finishes, and accuracy by jetting the two materials at the same time. At the same time, we enjoy the FDM technology with its true thermal plastics that are deposited. This is not about simulated or first-generation plastics. This is about true thermal plastic. And it's filament material that's advanced up to the extrusion head, heated and extruded out at 7 or 10 thousandths of a layer, for instance, and which to create a robust part. So both technologies are complementary and mainstream in engineering prototyping, but also product development and, again, additive manufacturing processes. So to take a closer look at what's possible within it, what I call the fuel, let's look at the PolyJet photopolymer materials first. There's rigid, opaque, clear, transparent, high temperature, digital ABS. Next, there's flexible materials, which provide an array of shore values just from the base material. We also have medical-grade materials that are biocompatible for dental and hearing aids, and they carry an ISO 10993 and USP Class 6 certification. This is a strong offering. Before we even get to the multitude of choices on the digital composite material process, I'm going to get into what that is in just a few more slides. Now I'm going to move to the other side and talk about the thermoplastics offered by the FDM process. Here we're talking about durable, true ABS, the strength of polycarbonate ABS blend, and a strength that offers 96 joules per meter of material. These are industry-ready materials. They can be sterilized for food and drug applications. And finally, we move into the high-performance materials such as Ultim and PPSF, which open up a whole new field of applications with their rating, its rating of flame, smoke, and toxicity certification. So now let's look at the plastic pyramid. Here you can see the different categories. On the very bottom is represented with the standard plastics. In the middle is engineering grade, and at the top is high performance plastics. Today, annual consumption of plastics, believe it or not, is at 300 million tons. And just looking back to 1950, the annual consumption of plastics was at 5 million tons. Now, we're talking about 17,000 different types of plastics that make up this usage. So plastics is definitely a success story in and of itself. So as you see in this pyramid, as you go up, the higher the performance pyramid is greater thermal, mechanical, and toughness properties. So this really has been our roadmap, and the fact that plastics is just growing beyond belief. So this roadmap, it gives us the direction for material development, which we're always striving to get greater overall properties across each of our platforms. So up till now, up at the top of the pyramid, we see the high performance offered by Ultim, and you can see in the middle the polycarbonate falls, as well as the digital ABS and all of the others in the standard plastics category. So it's a good offering of materials, well balanced. Now this is the thermoplastics broken down specifically for the FDM side. I've circled the PPSF and the Ultim. Once again, the Ultim has is a FST, so flame, smoke, and toxicity rating. So that's really going to lend itself well for some higher temperature applications. And the PPSF is chemically resistant to gasoline, motor oil, and transmission fluid, for example. And there's a whole laundry list of things that it's resistant to. So these are the two, as well as many others that are listed here, but these two I'd like to point out specifically for the automotive industry. So on the object materials, we heard Eric talk about going into some of the specific applications that he's using it for, such as lenses. But right now with the PolyJet base materials, we can offer many different base materials, going from rubber-like to polypropylene-like, as well as getting into more rigid materials and then those medical-grade materials. And that's all before we talk about the digital materials, which once you add those in, the object technology offers 123 different material opportunities. So looking at I've talked about the FDM, I've talked about the PolyJet. So I'm going to show you a couple applications where both technologies were used as a complement in an application. So Formula SAE is a student design competition organized by the Society of Automotive Engineers. The competition was started in 1978, and it involves students around the world. And each team designs, builds, and tests races a small-scale formula-style racing car. So this year's competition, a fourth-year student of automotive engineering used a combination of FDM materials as well as PolyJet materials within his design. So you can see here a working model of you can see online a working model of the Stratasys materials. And it's creating a hybrid functional prototype, which then becomes part of the final car. So once again, the Ultim material was used. That's the gold material that you see there. It was used for the airbox for the high temperature resistance. So the temperature resistance is at 120 C, and also vibration resistance were required here. So the Ultim was the perfect choice there. Meanwhile, the digital ABS is what you see with the green. This was used for the plenum chamber, where the airbox requires a combination of toughness, and a unique geometry for its high surface finish. And then in addition to this, the Vero Clear transparent material was used to create a small oval window to see inside the airbox. So it's a good example of both technologies at work. Here's an example of a case study that highlights the successful application of creating colorless and transparent light guides, such as what we saw with Eric's presentation. So Vero Clear is a good simulation of PMMA, or better trade name known as plexiglass. So finishing FDM and polyjet parts, we heard Eric talk about doing some high techniques with high quality finishing and painting. So clearly Prefect has refined the expertise in this area. However, applying some simple techniques such as sanding and, again, applying primer are very common. And this is where all of our customers can create painted, plated, and lacquered parts with great results. Here's an example of an object part that has been glued together. So there's 4 different areas. One's been lacquered, the next primered, the next plated. So you can see that this is a really nice example of the different finishing levels that you can create. So painting and gluing is easily done. That's obviously demonstrated in the last hubcap example, or rim. Metal coating is also frequently done with all of our materials. So just we have tech guides on that to help you be successful in that application. And in this particular case, it is allowing this customer to not only create a more aesthetically pleasing part for showroom quality, but it's actually functional. It's creating a stronger, higher application or rough part where it can actually be utilized for the application that it was intended for. So Eric talked about the conic system. I've made reference to digital materials. I want to talk about that a little bit further because some people understand the concept, but it's a little difficult to fully grasp the fact that you can create 123 different material options from this technology. So digital materials is really a composite, and composites have always existed. So you look at adding strata mud. That idea is to create a stronger wall. You add rebarb into concrete construction. That's going to create a stronger structural result for the building. So how do we create digital materials? This is all about an algorithm. This is all about software. Digital materials do not exist in a cartridge, but rather being composed by the software. Here we see a primary material, kind of denoted here with some of the dot matrix that you see. It's being composed by the software. And then we can see a primary, so a secondary material, which is either rigid or flexible, either or. And the 2 different materials create a new composition that has new attributes. So it's actually taking 2 different materials and creating a new material. So on the Conic platform, for instance, you can produce a mixed tray, just with white or black, for example, which is what you're seeing here. You can do rigid or rubber-like, transparent, and opaque. It's all about a mixed tray, and 2 materials that are loaded does not require you to change the cartridge. At the same time, you can design and print a mixed material part. This is an option that combines the 2 different materials into one build. So that's the second one that you see in the middle. And the last option is to jet both materials to create that digital material. So again, people have a hard time understanding this concept. So what helps to understand is, once again, that it doesn't start out in a cartridge. Digital materials are created from the cartridge-based materials and composed together to create that new material. It's not a homogeneous mixture. It's composed with the 2 base to create that next one on the fly. This is another good demonstration of the 2 materials being utilized. Material A and material B are denoted here. So the first is a mixed part. The second is a digital material where it's composing the 2 materials. So once that is achieved, you can see the different pictures are trying to show a different structure which is created by that digital material. And it's only achievable through this process and not through a single cartridge technology. So what does it look like if you build an entire 14 material part on the fly? What you're seeing here are different colors, but those different colors are denoting a different material characteristic. So if you look closely, you can see different shore values being called out, different elongation to break properties. So depending on what you're making and the type of material properties that you need, you can absolutely try to achieve this through the use of digital materials. So if I sum it up, it's all about two base materials that are helping us create 12 digital materials in one build, so rubber-like and rigid, with all different properties in a single build. It's all about allowing you to create a wide variety of products and to provide you everything from rigid parts to soft touch and everything in between. So these digital materials, with every new base material, it's going to allow us even more digital material combinations. So you can see here some of the inherent applications for this. This ability is creating coating, shock absorption, gaskets and seals, living hinges. So the applications that our customers and we are discovering just continue to grow. So the 3D revolution is really happening now. The reason why I say that is not only from the Gartner Technology Report, but also the fact that governments are now accepting the idea that 3D printing is an economic driver. For instance, Obama administration pledged funding of $60 million in the National Additive Manufacturing Innovation Institute. The European government is also investing in this area. So looking forward, the solution will require educating and qualifying new generation of engineers. And that's really what's happening here is we are all realizing what an economic driver this is and how it's affecting the different industries. So to sum everything up, I know I've shared a lot with you. Rapid prototyping really started all about the fit, form, and function of design. Taking that forward, it went into design verification. And through the growth of enhanced materials or the offering of enhanced materials, this has allowed our customers to start utilizing the printed parts in a manner in which it needs a lot of strength. So now they can actually verify that design. Additionally, for end-use parts, the use of Ultim, for instance, in the aircraft industry, because of this FST certification and the fact that they can create end parts in the aircraft itself. Custom prosthetic limbs can be created because they're strong and lightweight. Injection molding prototyping parts can be made, like I showed earlier. Jigs and fixtures we also talked about. The custom entertainment and costume design sets, this all lends itself, such as, I'm going to make the strange comparison. You look at how beautifully finished some of those car parts were from Eric's presentation. It's the same idea with the entertainment industry. The fact that the materials are so strong and can be finished so nicely, it lends itself well. Medical design and surgical applications, as well as dental, the fact that we have biocompatible materials, all of this makes up for a well-rounded product offering in lean manufacturing, end-use parts, and everything in between. So once again, I'd really like to thank you for this time and sharing this information with you. Just like Eric said, if you have any follow-up questions that we don't address today, feel free to contact us directly or contact each of our individual company websites to find out more information on the technology and our product offering and materials. Jim?
Susan, thank you. That was very, very comprehensive, and you covered a lot of material there with those slides. Hello, this is Jim Sawyer joining you again. Our attendees have literally peppered us with questions, and we'd like to get to all of them before time runs out, so let's get started. The first question here is for Eric and maybe Susan regarding plating. This person says, none of my standard platers have any experience plating photopolymer parts. Do you have any tips for background information that I need when talking to them about doing this? What processes work and what are the best techniques?
Jim, I'd be happy to answer that question, at least from our perspective. We often, most of our parts, especially in lighting, require a vacuum metallization process, which many are probably familiar with. And we also have worked to develop actually a spray-on chrome process where we can chrome the parts through kind of a paint-based system, but it actually produces a truly reflective finish. But additionally, the most important part we've had with this whole thing is making sure your surface preparation is strong, because especially in metallization, if you don't have a good surface finish, before you metallize or do the spray-on chrome, you won't have anything to speak of when you have a finished product.
Susan, anything to add to that?
Oh, sorry about that. I put myself on mute. Yeah, that's so great information, Eric. I agree. The vacuum metallization process lends itself very well. And just to help you one step further, 2 words of advice is, one, again, on our website, we have some how-to guides. So that is going to, some technology guides that's going to help you be successful. But absolutely, feel free to contact us, specifically our application engineering group, because they can help you with, pointing you in the right direction on the nuances of being successful, but also possibly recommending some places that have some experience with that.
All right. Another question for Eric. Is the connects that Prefix uses for end-user products as well as prototype products?
Yes, absolutely. I think that one of the things that has really changed in the industry is kind of what the expectation is for an end-user product. I mean, traditionally we've talked about, toys and what have you that are, come in the, at Walmart or whatever, but the marketplace is truly changing with the ability to actually print, atypical end-user products such as toys or, little dinosaur heads or whatever, as was one of the sales tools that was given to us. But you can actually create, physical properties that you could definitely call end-user products. I think it's just changing the game about what really truly is an end-user product.
All right. And one for Susan. How many different materials can be loaded in a printer at any one time? I imagine that depends on which printer it is, but can you load
Absolutely.
14 materials in a single printer and use them in sequence?
Okay. So to answer that question, you can load 2 different material cartridges into the Connex at one time. With these 2 different materials, again, specific to the Connex, you can create an additional 12 material composites, which then gives you the ability to run 14 materials in one build. And that's just, again, goes back to the 2 specific material cartridges that are loaded.
Okay. Are there any machines from Stratasys that hold more than 2 cartridges so you could have multiple loads of materials in them?
Looking at the Connex 1000, that's going to provide you a little bit more. That is the highest level or largest system that we have. But the Connex 500, I believe, is what Prefix has. That has 4 cartridge bays, and that's 2 support and 2 model.
Okay. Now here's one that I'd like both of you to address. What do you feel is the best software? In other words, is there a discipline that one software is more advanced in, suiting 3D printing, additive manufacturing better than others? What should an industrial designer look for and concentrate in learning how to use these technologies?
Eric, I'll let you field that one first.
Well, I guess I'm not totally sure of the question, but just to give a little background on what we do, I guess. We use CATIA and NX typically in our CAD design. We get data from our customers, whether it be Ford or Chrysler or a lighting supplier or whatever, and then we analyze the data. Usually it comes in either CATIA or NX. but we have to ultimately export it as an STL file that then gets loaded into the Object Studio software for fitting onto the platform and ultimately producing the part. So I'm not sure if that's answering the question, but that's what we operate in essentially, is either CATIA or UGNX.
Okay, and is there any difficulty in translating from one software to the next? Is that fairly automatic, or is that something that you have to labor over?
Yeah, typically it is not an issue. However, we have used the software called Magix that often can help with any of the imperfections in the data to help assure that there's no holes, because they have to be a solid in order to be watertight so that they can be produced on the machine. But again, it's that's few and far between. But we have that additional software application if necessary.
Susan, anything to add to that?
I agree, and I thank you, Eric, for fielding that first. I wanted to get a voice of of our customer experience on that. I've seen so many different types of software being used, and really it all depends on the company and the industry. I wouldn't say there's one best software. It really is whether or not it has the ability to output it as a good sound STL file. And then I agree with the use of Materialize Magix. That can go in, and you can do a lot of things with that third-party software, such as fixing any STL files, as well as doing things as labeling, or even doing some dovetailing if you need to cut some parts up for gluing or fitting together later.
Very good. Another one here for Eric. And this is a very interesting one. Eric, what were you looking at when you were thinking about getting a 3D printer? What stood out in your mind? What features and capabilities were you interested in, and what made you decide on going with this technology?
Ultimately, we had a couple factors that we really needed to consider. One was the size of the parts that we have to make. I mean, we looked at some smaller tables, but we knew that we would be so limited, and we basically took all the parts, the variety of parts that we have to make, and said, we need to get a table that can cover, say, roughly 90% of the parts that we're going to make, because we didn't want to be restricted and have to outsource a part because it wouldn't fit on our table. However, we didn't necessarily want to get too large of a table due to added expense, and if we could fit it on something that was a little bit smaller. And so the combination of things that the Connex 500 provided was a good size that we could fit the majority of our parts, but additionally it was a very, very high quality. I mean, ultimately it's the highest quality build that you can make. And we have, in lighting, as many may know, there are a large number of very detailed parts that if you look at standard SLA technology, you simply won't be able to get the quality that you want and the detail that we would need. And so those combination of things really were the key factors for us in ultimately making our decision.
All right. And here's another very good one. This one I'll send over to Susan. Are there any methods currently being used for materials recycling for 3D printed parts? This may be a different answer than they're looking for, but we actually do a recycling program of our canisters and cartridges to be a green company as far as that goes. On the specific materials, the fact that it is a plastic, it depends on what technology and what material. So it really boils down to the specific local-based type of recycling program. So it's something that you'll need to find out what your local recycling process is and whether or not it falls within those limits. All right. And again, for Susan, what is the maximum part size that can be 3D printed today? The Fortis 900 has a build envelope of 36 by 24 by 36. So, if you really wanted to create like a big old box, that's what you'd get. The Connex 1000 is about 39 by 31 by 19.
So those are within the envelope constraints. However, let me challenge you to think beyond the actual envelope build, because as I referenced before, in Mimics you can create dovetailing. You can also do that in CAD files, and you can absolutely bond parts together, such as what I showed in my presentation. So by building a part, or something that's as big as an aircraft landing gear we've built in pieces and glued them together. So really, it's limitless how big you can build, how big your part could be because of that ability. But if you're just talking about the machine constraints, those are the sizes that I just mentioned.
Okay. Eric, you mentioned that you do run lights out with your printer. Do you have some sort of alarm that would alert personnel, whether they're on site or whether they might be off site, say the building's empty, that would call their cell phone and let them know there's a problem?
We have a couple different fail-safes, if you will, in place. First and foremost, the software actually has a pretty good calculator as part of it, that once you set up a table, that it tells you when the table is going to end. And so, we're able to make a decent monitor of the fact that it may say that it's going to end, Friday at 3 p.m., and so we're aware of that. But additionally, we have our software all linked to our email and cell phone via text message, so we get alerts when the software or when the resin or support is running low, when a table has finished. And lastly, we also have a Log Me In account basically on our phones and other computers, so that we can log into the object computer and actually check on its status. So, I've often, checked it at 10:30 at night and see that it's going to end in 20 minutes, and then, you align it and you leave just in time and get there so that you can change it out and, do the whole thing in 20 or 30 minutes. So we're pretty in tune with the machine, and we're all pretty well aware of when it's going to end.
Okay. Well, we're almost out of time, so we'll throw out one more question, and this one is to Susan. What are the primary industries that Stratasys 3D printing is used within?
Wow, that's a great question indeed. Primary industries is deceiving, because I can say that literally every and any industry is using it now. Well, maybe that's a bit extreme, but I had showed you a slide at one point in my presentation that talked about footwear, toys, dental, things such as aligners for dentistry, as well as dental guides. In architecture, they're replacing some of their foam and cardboard fabrication. Consumer goods, as far as electronics, where you can put in the housings and actually make a functional consumer electronics part. Aerospace and defense, that's lending itself well with like the Ultim material that you can create in production parts, as well as automotive, like we heard today, and medical and devices and surgical planning. So those are just a few, for instance, but we just have an array of industries out there, and what's the only thing that limits us is our creativity, right?
Absolutely. Well, our time is just about up. We do have a few unanswered questions. We will pass those along so that answers can be sent out via email. I would like to say that both of our presenters proved that 3D printing is an exciting technology that has achieved great things already, but it has not even begun to reach its peak. Both SME and manufacturing engineering media have a long involvement with 3D printing, rapid and additive manufacturing that extends back better than 20 years. For instance, SME's rapid technologies and additive manufacturing community feature member discussions, certification, rapid exhibit information, and much more. And for more information on that, you may visit the first website shown on this slide. In addition, ME Media delivers the latest rapid and additive news and information on our website at the second link shown on your screen. I'd like to thank you all for joining us today. We hope you found this webinar of great benefit.